Good morning, ladies and gentlemen. Welcome to week 24 of your SAT Math Prep series. This week's topic is trigonometry and similarity. I say trigonometry and similarity because basically what we're looking at here are right triangle problems. Now, this could involve several different things: trigonometry, similar triangles, and Pythagorean theorem, which is why we've waited until this point in the year to cover this type of problem, because in your geometry classes you have now covered all three of those topics. So again, these are problems that are generally considered to be medium to hard, although I will say that I don't think they're nearly as hard as some of the others that are named medium and hard. So please make sure that you're taking good notes here and that you get this information down on your guided notes so that you have it available to you when it comes time to work through the quiz. Okay. So here's the problem types we're looking at. First problem here says, in the triangle shown, which is triangle ABC to the right there, which of the following is equivalent to AC over AB? Now when we see AC over AB, we have to realize that that is a ratio and that we're dealing with a right triangle, which means this is a SOHCAHTOA problem, which should also be seen there in the answer possibilities. Okay, so we need to remember that SOHCAHTOA stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now the big key here is that we need to be able to recognize that AB is the hypotenuse, and then we have to realize that the other two sides are actually dependent on which angle we are talking about. For instance, BC is opposite angle A, however it is adjacent for angle B, whereas AC is opposite for angle B and adjacent for angle A. So when we are looking at AC over AB, we have to figure out, well, which one of these trig ratios that's given in the problem is the correct trig ratio. So for instance, sine of A is the one that I put in blue. So since sine is opposite over hypotenuse, that would be the blue opposite over the hypotenuse. In other words, that would be BC over AB, which is not the correct ratio. That is not what we're looking for. So that is not the correct answer. Okay, the cosine of angle B would be the red adjacent, the adjacent side to angle B, which is BC, over the hypotenuse, which is AB. Again, that does not match the answer that we're looking for. That is not correct. The tangent of angle A would be opposite over adjacent, and we'd be using the blue because angle A was named with the blue. So that would be BC over AC. That is also not what we're looking for. Whereas the sine of B is opposite over hypotenuse using the red labels. So the red opposite over the hypotenuse, which would be AC over, over the hypotenuse, which is AB. That is the correct one because that is the one that's equal to AC over AB. So the answer would be D. So that's the first way we could see this on the SAT, and the big thing to notice here is that we have to recognize what type of problem we're dealing with. we have to recognize that that is in fact a SOHCAHTOA problem, and that the fraction that they're asking us to find is in fact one of these four trig ratios. And again, the key is it all comes back to naming the sides. If you can do this part correctly, you will get the answer correct. Okay, on to the next one. Example 2 says triangles ABC and DEF are shown below. Which of the following is equal to the cosine of angle B? So, the first thing we have to notice is that we have a similarity statement. We are told triangle ABC is similar to triangle DEF. Now we need to remember that similarity does not guarantee that those two triangles are congruent, but it does guarantee that those two triangles are the same shape, meaning that angle A and angle D, well, I wrote that wrong on this problem, should be ABC and, okay, they are similar triangles. And the reason we know that, I said that wrong, so we should probably just start this whole thing over here, okay? We should realize that these are similar triangles because we can figure out the measure of the third angle. We have a 90-degree angle and a 32-degree angle, which means that the measure of angle B has to be 180, because all triangles add up to 180 degrees, minus 90 minus 32, which would be 58 degrees. Similarly, in the other triangle, we have a 90-degree angle, which means that angle E would be 180 minus 90 minus 58, or 32 degrees. Which means these are similar triangles, but I've got that label wrong. Okay? If we're looking at this similarity statement, angle A is congruent to angle E. So if A comes first, then E should come first. Angle B is congruent to angle D, so D would come next. And then angle C and F, those are the right angles. So triangle ABC is similar to triangle EDF. Now, the reason why we care is very simple. If those are similar triangles, then the sine of angle A is equal to the sine of angle E. The cosine of angle A is equal to the cosine of angle E, etc., which means that the cosine of angle B would be equal to the cosine of angle D. So when it says which is equivalent to the cosine of angle B, well, if we're naming based on angle B, or its equivalent in the other triangle, angle D, we can name the sides of that triangle based on that. So in triangle ABC, that would make AC the opposite side and BC the adjacent side. Of course, AB, which is opposite the 90-degree angle, is still the hypotenuse. Same in the other triangle. Since it's opposite the right angle, DE is the hypotenuse. And if we're naming based on angle D, then EF would be my opposite and DF would be my adjacent. So it says, which is equivalent to the cosine of angle B? Well, in this triangle, the cosine of angle B is adjacent over hypotenuse, which would be BC over AB. So our first check should be for that ratio. That ratio does not exist in any of our answers. So then we look at the other triangle, and we have to realize that the cosine of angle D is the same as the cosine of angle B. Because B and D are congruent angles, they have the same trig values. So the cosine of angle D would be adjacent over hypotenuse in that triangle, which would be DF over DE. The correct answer is C. Now these others, they're all equivalent to trig functions. Okay, EF over DF is opposite over adjacent. That is the tangent of angle D, which would be equal to the tangent of angle B. AC over AB would be the sine of angle B, or the sine of angle D. We just figured out DF over DE is in fact the cosine of angle D, which is equivalent to the cosine of angle B. That's the correct answer. And then EF over DE would be the sine of angle D, which means it would be equivalent to the sine of angle B, which is not the correct answer. Okay? So again, it's all about abstract trigonometry. Do we know sine, cosine, and tangent, SOHCAHTOA, well enough? Do we understand that in similar triangles, those trig functions would be the same? Okay. The last one is a bit more direct, but it does involve one extra step. So on to the third example. So this triangle ABC is shown below. The sine of angle B equals 5 over 13. What is the length of side BC? Well, if we're naming the triangle based on angle B, we have the hypotenuse as 26. AC would be the opposite side, and BC would be the adjacent side. If we are given that the sine of angle B is equal to 5 over 13, that is equivalent to opposite over hypotenuse, because sine is equal to opposite over hypotenuse. We don't know what that opposite is, so let's put a variable in there. We have 5 over 13 equals x over 26. This is a proportion that we can solve to find the length of side AC. I know what you're thinking. Why would I want to do that? Well, if we know 2 of the 3 sides, then we can find the third. So we would take that proportion, we would cross multiply to give us 13x equals 130. Then we would divide to get x. We would divide by 13, which would give us that x equals 10. Well, that's the length of AC. So this is 10. Now the reason why we care is because now we can turn around and we can use the Pythagorean theorem to find the length of BC. See, we don't know what it is either, so we'll call it y. And we have that the y squared plus 10 squared has to equal 26 squared. This is a right triangle, so we can use Pythagorean theorem. So 10 squared is 100, 26 squared is 676. We would then subtract 100 from each side, which would give us that y squared is 576. And then we would take the square root to get y by itself, which means that y is 24, which means that's the length of side BC. It's 24 units, or C. So again, folks, these problems are difficult not because the actual math behind them is difficult, but because we have to understand such a wide variety of things, and we have to be able to recall and recognize these things. Triangle similarity, Pythagorean theorem, SOHCAHTOA. All of these things could come into play. So it's more like a capstone problem, like we're putting it all together. Hopefully you've taken good notes and you have these examples available and you are free to use them on your skill check. Once again, your skill check can be found by going to Google Classroom. The game will be there. The link will be available right on Monday's date, which is, Tuesday's date, which will be the post for April 12th, 2022. Thank you very much for your time and attention.